Welcome everyone to this week's Science News. Today we'll talk about water on the moon, space skin, quantum light, how crystals grow, mind-controlled robots, blood as fuel, nano ink, a new projection for population growth, and of course, the telephone will ring. Two new analyses have discovered sources of water on the moon that could improve prospects for a human space station there. The first, which has got a lot of press, is an analysis of moon soil that was returned by a robotic arm from the Chinese mission Chang'e 5 in 2020. They found that the soil contains glass beads, which are created by asteroid impacts, and those beads contain water. In this study, they sampled 117 glass beads and extrapolated that lunar soil may in total contain as much as 300 billion tons of water. That's a lot more than anyone thought. The second paper is a spectroscopic analysis from SOFIA, the Stratospheric Observatory for Infrared Astronomy. It was a joint US-German project that was flying a telescope around Earth in a Boeing 747. The mission was discontinued last year because the costs didn't justify the results. However, their measurements covered about a quarter of the Earth-facing side of the moon below 60 degrees of latitude. This includes the south pole of the moon, where a prior study had found water. The new analysis confirms this. The blue parts in this image are where there's more water. Notwithstanding what Pink Floyd had to say about the matter, the moon doesn't have a permanently dark side. It does, however, have parts that are permanently in the shadow because they're surrounded by crater walls. The new analysis also found that parts of the moon in permanent shadow are wetter. So if you're on the moon and the kettle's empty at tea time, look in the shadows. These are interesting developments because both the United States and China have plans to go back to the moon, more than 50 years after the last humans walked there. NASA has a new generation of spacecraft, Orion, that have been tested since 2014 and that they want to use to put people back on the moon. The first uncrewed test, Artemis 1, lifted off successfully in November last year after several postponements. The next mission, Artemis 2, will also fly around the moon, but it'll be crewed by 4 people. It's currently planned for 2024. For Artemis 3, NASA is working with SpaceX. This mission is scheduled to land on the moon in 2025. The exact landing site has not yet been determined. NASA's not alone with its lunar plans. The Chinese Space Agency already has a remote-controlled vehicle on the moon and wants to drop humans there too. And 3 private companies, iSpace, Astrobotics and Intuitive Machines, also want to put devices on the moon, though they aren't currently planning staffed missions. Beyond that, there are vague plans to set up a permanent base on the moon. It's scientifically interesting because the moon has almost no seismic activity and no atmosphere to get in the way of a telescope, so it's a great place for sensitive measurements and observations. One could also use the base to launch service missions to satellites or mine helium-3, which can be used for nuclear fusion. Knowing that there's water on the moon and where it is super useful for moon base plans because one can use sunlight to extract the hydrogen from the water and use the hydrogen as fuel. And the people on the moon base might appreciate a cup of tea that wasn't made from recycled urine. A team of researchers at the University of Surrey has developed a nanomaterial that protects spacecraft from radiation damage and electrostatic discharge. They're calling it a space skin. Materials used for equipment that travels in space must be able to withstand the intense radiation from charged particles and temperature extremes in outer space. Scientists have experimented with some new materials for that. For example, silicon carbides, silicon nitrides, or the patented product Zero Dur that was used for the mirrors for the Keck telescopes on Mauna Kea on Hawaii and also for the primary mirror of the Hubble Space Telescope. All these materials are robust and stable when exposed to extreme temperatures, but they are fragile, heavy and expensive. Something else that scientists have tried are polymers reinforced by carbon fiber. Such materials are extremely strong, lightweight, and keep their shape even at extreme temperatures. BMW has used carbon reinforced polymers for about 20 years to keep the weight of their vehicles down. It's also been used for the rotor blades and legs of the Mars Ingenuity helicopter, which has a total weight of only 1.8 kilograms. Unfortunately, carbon reinforced polymers get damaged by cosmic radiation, and they can build up static electricity, which you don't want to happen to sensitive equipment in outer space. So the authors of the new paper had the idea of coating this stuff with something else. For their space coating, the researchers applied several layers of carbon and aluminium by vaporizing them and then depositing the materials very thinly on top of each other. The total coating in the end is less than 1 micrometer thick. You can see in this image what happens to the carbon-enhanced polymer when it's exposed to radiation. The uncoated version is in the top line of images and the coated one at the bottom. One sees the difference very clearly. The researchers say their coated material checks all the boxes. This coating is an example of what's called a superlattice. That's layers of different materials, usually only a few nanometers thick, which are themselves lattices. So a one-dimensional lattice of lattices, a superlattice. A superlattice should not be confused with a superlattice. That's how Liz Truss plans to return to power. A team of European physicists has made a breakthrough in the attempt to manipulate quantum light. Isn't all light quantum light because it's made of quanta? The quanta of light? Yes, indeed. Those quanta of light are called photons, and they're one of the fundamental particles in the standard model of particle physics. What they looked at in this paper are bound states of those photons that can be created in certain materials. Those photons belong together and act like new particles with properties quite different from individual photons. These bound states are a type of quasi-particle. They're interesting because their properties can be customized, so they could potentially be used for quantum computing. Curiously enough, if you put photons into an empty cavity where they can interact with the walls, they behave similar to photons in a medium, even if there's no medium in the cavity. There's even a name for it. It's called cavity quantum electrodynamics. Those bound states of photons are interesting because they can interact with each other. Normal photons don't do that. They just go through each other. This is why we can see, basically, so usually it's a good thing. However, if you want to compute with photons, then getting them to interact would be handy. So that's why physicists are studying those bound states. Why is it called quantum light? I've never heard this expression before, and it actually doesn't appear in the paper, just in the press release, so I'd suggest you just ignore it. What the paper deals with are those bound states of photons in a cavity. In this experiment, they wanted to confirm that the photon bound states behave as predicted and indeed behave differently than single photons. To show that, they started with a semiconductor quantum dot, which is basically a simulated atom, and put that in a one-sided optical cavity. You can see the dot here in the middle of the blue circle at the bottom of the diagram. Then they shot pulses of light at the quantum dot. It absorbed a single photon pulse and then shot the photon back out again, where its arrival at a detector was timed. That's depicted here on the top right of the diagram. Then they did the same thing with bound states of photons, and the dot reacted differently, just as predicted, spitting them out faster. The results of the measurements were consistent with the theoretical expectations. Here the red line shows the theoretical modeling of the photon bound states. The blue dots are the experimental results. This is an artist's representation. It's supposed to show that the single photon is slower than the pair of bound photons, and the fastest of all is the three bound together. Quite a nice illustration, isn't it? One could call it photogenic, though I admit it isn't exactly light news. Researchers in Illinois have taken a video of how nanoparticles assemble to crystals. They took nano-sized gold cubes and put them into deionized water, which at first keeps the cubes separated. Then they changed the pH value of the water, which causes the nanoparticles of gold to grow into a lattice. They used an electron microscope to figure out what's happening, which is what you see here. The little gold dots on the left are the centers of each nanocube. You can see that they are jumbling together in horizontal layers and then stacking vertically, sort of like school children jostling for a place in a line. But unlike school children, once they find their spot, they stay there, locked in place. The researchers used this to come up with a computer model for how the process works, and here's an animation of the same nanocubes. If you look here at the top, you can see a single nanocube poised on the edge of this layer, as if it's wondering what to do and then falling into the layer below. Understanding how crystals grow could come in handy as a new way of creating microscopic electronics. Mr. President. Oh, they created a long and more robust memory for quantum computers. No, I hadn't seen that. How long did it last? 10 seconds. That's exactly what I would call a long and robust memory. Well, the best way to safely store your data is to not store it in the first place, so quantum computers will be ultra safe. Always at your service. A team of Australian researchers has developed a device that allows you to control a robot just by thinking. Basically, it's a sensor that you wear around your head, attached to an augmented reality lens at the front. The sensor is less than a nanometer thick and made of graphene. It picks up brain waves from the visual cortex at the back of the skull. The person using it sees commands on the AR lens, focuses on those, the sensor picks it up and relays the command to the robot, which enacts it. You might ask, what's the point? Couldn't you just track the eye movement? Yes, you could, but the new system could one day also read signals from your brain about, say, motion commands to your arms and hands, even though you're not moving them. The innovation here is that these sensors are extremely thin and still work when you're sweating, which is an issue with the more common skin electrodes. This research was partly funded by the Australian military, and the prototype in this experiment was what the Australian Army calls its Ghost Robotics quadruped robot, which is a robot dog. It followed commands with 94% accuracy, which leaves the other 6% for a great horror movie. A team of Swiss researchers has built an implantable device that creates electricity from blood and uses the electricity for a device that controls insulin levels. Basically, it's a fuel cell made of different types of specifically designed nanomaterials that gets implanted under the skin. When the blood sugar level drops, the fuel cell uses some of that sugar to produce electricity. The electricity powers up a bioelectronic circuit which releases insulin to bring blood sugar down to a normal level. Then the fuel cell turns itself off. To test whether the idea works, they implanted the device in mice with type 1 diabetes. Unfortunately, the researchers saw a significant dip in performance of the fuel cell when implanted. They haven't really figured out why that is, but hope that further work will improve the performance. They also say that the device generates enough electricity to talk to a smartphone app, which presumably can then broadcast your health status on Twitter. A group of material engineers at the University of Melbourne has developed inks with nanoparticles that could be used to maintain pleasant temperatures in buildings. The idea is that these inks could be sprayed to the outside walls and keep it warm inside when it's cold outside and cool inside when it's hot outside. The nanoparticles in the ink are made from vanadium oxides. These compounds have what's known as an insulator to metal transition, which means they can shift from absorbing heat to deflecting it. This can be used to control the amount of infrared radiation that passes through. Unfortunately, the switch for the transition in vanadium oxides is typically at a temperature of about 68 degrees Celsius, which is well above the temperature where you want the cooling effect to kick in. But the Melbourne team was able to engineer the properties of the material so that they transition already between 30 and 40 degrees Celsius. They managed to do that by controlling the amount of water and oxygen content in the materials. This creates an internal strain in the material and in return changes the transition temperature. These inks could not only be used on buildings but also on electronic devices and clothing that I'm sure will make you look very environmentally friendly as you turn the air conditioner to deep freeze. The Swedish Global Challenges Foundation has published 2 new projections for the number of people on our planet depending on policy decisions. The first projection is what the authors call too little too late. In this scenario, we manage to turn around carbon emissions basically tomorrow, but everything else continues as usual. Is it just me, or does this make absolutely no sense? In any case, this projection puts the peak of the global population at nearly 9 billion in 2046. This figure is somewhat confusing. I think what you want to pay attention to is the curve of well-being, which keeps on dropping. This scenario is accompanied by a steady increase in income inequality, huge losses of wildlife, declining trust in government, and puts many economies at risk of collapse. Very cheerful. The second scenario is called the Giant Leap and assumes a revolution in global policies. Poverty is basically eliminated, wealth inequality decreases, food systems become sustainable, and energy clean. In this case, the population peaks at 8.5 billion in 2040, well-being improves, and everyone is rich and happy ever after. I don't know why many of the curves in this study seem to have a periodic oscillation of 5 years or so, and both of these new projections differ significantly from those of a study published in The Lancet in 2020 that I told you about a while ago. According to the Lancet forecast, the global population will peak in the year 2064 or so at about 9.7 billion. The UN has their own projection, which puts the peak of the global population even later in the century at an even higher number. This isn't my research area, but having looked at all those projections, the Lancet study seems the most reliable to me. Population projections are important because while everyone is blaming countries for their carbon dioxide emissions per capita, what matters in the end is the total emissions. And by all reasonable expectations, more people mean more carbon emissions. That is to say, I'm afraid that even the dystopian too little too late scenario of the new study is overly optimistic. So keep on dusting those solar panels, guys. There's so much going on in science, it can be hard to keep track. But that's what I'm here for, to keep track of the news, so you don't have to. But I can't think for you. If you want to really understand the science behind the news, quantum mechanics and renewable energies and astrophysics and chemistry and the mathematics that it's all built on, then I know just the right place for you, Brilliant.org, who have been sponsoring this video. Brilliant.org offers courses on a large variety of topics in science and mathematics. It's a fresh and new approach to learning with interactive visualizations and follow-up questions. Brilliant lets you pursue your own interests at your own pace. Whether you want to know more about solar panels, neural networks, astrophysics, special relativity, or computational biology, Brilliant has you covered. And they're adding new content each month. I even have my own course on Brilliant. That's an introduction to quantum mechanics. It doesn't require you to bring background knowledge, and it covers topics such as interference, superpositions and entanglement, the uncertainty principle, and Bell's theorem. And afterwards, maybe you want to continue learning more about quantum computing or neural networks. If you're interested in trying Brilliant out, use our link brilliant.org/Sabine and sign up for free. You'll get to try out everything Brilliant has to offer for 30 days, and the first 200 subscribers using this link will get 20% off the annual premium subscription. Thanks for watching. See you next week.